So this one wants us to actually use a quadratic to solve this situation. So two numbers with a sum of 4. So that means we have x plus y equal to 4 and a product of 5. So x, y equal to 5. So what we really want to do there is kind of manipulate this to where we have one quadratic equation. So that means we're going to take this first equation and solve it for one of the two variables. We're going to solve it for y. All that means is we're going to subtract x from both sides. So this turns into y equal to negative x plus 4. Now we're going to take that and plug it into y for the second one. So it's x times negative x plus 4 equal to 5. We're going to distribute that x into the parentheses. So we have negative x squared plus 4x equal to 5. Now we have a quadratic here. We're going to subtract 5 from both sides. So we have negative x squared plus 4x minus 5 equal to 0. So now we have a quadratic to graph. So let's graph it here. Let's come up with some variable or some values in a table though. So for one, we know from what we learned earlier where our y-intercept is, right? Actually, that's too many blocks. We're not going to use that many. And looking at our graph, we're going to start negative 1, 0, 1, 2, 3, 4. So for instance, we know that at 0, that is up at 5, right? Actually, we're going to manipulate this equation a little bit because we don't want to deal with the negatives. So before I do anything else, I'm going to move everything over to the right side. So it's 0 equal to x squared minus 4x plus 5. It really doesn't matter either way, but just based on our graph that we're given here, we want to open up because it just looks that way. And again, our y-intercept is at 5. So that's our second point on our table. Plugging the numbers here, negative 1 squared is 1. Negative 4 times negative 1 is 4. So that's going to be positive 10. It's off our graph, so not worried about it. At 1, it's 1 squared minus 4, so that's negative 3 plus 5 is 2. At 2, 2 squared is 4. Negative 4 times 2 is negative 8. So that's going to be negative 4 plus 5 is 1. And then the other two I'm just going to tell you are 2 and 5. So notice there's no 0 in the right side. That's going to be a problem. So let's keep looking though. On our graph, at 1, we're at 2. At 2, we're at 1. At 3, we're at 2. And at 4, we're at 5. So this is our graph. So that is a problem. It doesn't cross the x-axis. So that means there are no real solutions. So this one here, same idea, same plan. We're going to solve this by graphing. If it can't be found, then state the consecutive integers where roots are located. So this one is a negative. That's fine. We're going to leave it that way. Let's fill in our table. 0, 1, 2, 3, 4. When we graph it, or we come up with our equations, or our solutions, so we plug in 0, we get negative 1. We plug in a 1, we get 2, 3, 2, negative 1. So plotting our points. That's what our graph looks like. And it does say in our answer, or our question, to state the consecutive integers that between which they are found. So that means that our solutions are between 0 and 1, and between 3 and 4. Of course, we can get exact numbers using a calculator, but that's why graphing isn't necessarily the easiest way, because you have to use a calculator to get your solutions. The next one is for you guys to try.